So this is the second lecture where we will deal with system of linear equations. Like here you can see we are given two equations which is called system of linear equations, and its solution is mentioned or can be written in this form: x naught and y naught in a point form. So we write its solution in a point form. So here you can see one example of system of linear equation. There are different ways to solve this system. First of all, we discuss by using graphing method. We can make the graph of this first equation, and we can make the graph of this second equation. The point where both equations intersects is called the solution of that solution of that system. Like here you can see this is the point of intersection, and that is the solution of this system. Similarly, here we have another example. We can solve it by using substitution. We call them 1 and 2. We substitute equation 1 into 2. Like wherever we see y, we substitute its value from equation 1. So it will become 2 times 2x plus 3 equals to minus 4. So it will be 4x plus 6 equals to minus 4, and it is 5x and minus 11. So x will be minus 11 by 5. So we can substitute this x into equation 1 or 2 to get y. So 2 minus 11 by 5 plus 3 equals to y. So minus 22, 15 minus 7 by 5 is your y. So the ordered pair will be, this is how we write minus 11 by 5 and minus 7 by 5. So this is the solution for this system. Or you can use the graphing calculator. You can plot this one, and the point of intersection is their solution. We have already done method of substitution. So the method of substitution solve one of the equation for either x or y. I call this first step that write any one equation in slope intercept form. So when you will write any one equation in slope intercept form, you can see we substitute this first equation into the second one, and the result will be like, I think there was some calculation mistake what I did. Here we get 5x. When this 6 will move to the other side, it will be minus 10. So x is minus 2. You can substitute x minus 2 into first equation or the second one, and you can get y. So here you can see another example. This equation is already in slope intercept form. You can simply substitute equation 2 into 1. So 3x minus 2, 2x minus 3 equals to 7. When we solve it for x, it will be like this. So here you can see we substitute y into this equation, so it will become 3x minus 4x plus 6. When this 6 will move to the other side, we will get x equals to minus 1, and we can substitute x equals to minus 1 into any one equation, and we can get y equals to minus 5. So there are some basic terms related to this. Consistent linear system is one that has one or more solutions. So that is called consistent linear solution. If a consistent system has exactly one solution, we call it a unique solution. It is said independent system. And if consistent system has more than one solution, we call it a dependent system. And then there is an inconsistent form. Linear system is one that has no solution, like maybe two lines are parallel. For example, if two lines are parallel, then there is no point of intersection, so it is inconsistent system. For example, if you plot this equation and this equation, you will see both of them will be parallel to each other, and you cannot find any point of intersection among them. Okay, so here you can see this is a system. Since each equation has the same slope, when each equation has the same slope, we say that this system is an inconsistent system. When they have different intercept and same slope, then it is inconsistent solution. For example, same slope, but different intercept. This is passing through this point and this one is passing through this point. They have different intercepts but same slope. And elimination method, we can make their variables, and like here, then we can subtract them. We multiply this first equation with the coefficient of x in the second equation minus 5, and we multiply this second equation with the coefficient of x in the first equation. So you can see the coefficient of x is same. So if we add these two equations, 10x will cancel out with minus 10x, so we will left with only y, and we can solve this equation for y. And similarly you can substitute this y equals to minus 1 in any one of the in any one equation given above, and you can solve it for x. So that would be your solution, minus 2 and minus 1. Here one more example of elimination. If I simply multiply this equation by 2, so it will become like this, and the current second equation will remain like this. So minus 1, if I add these two equations, we cancel out, so 0 equals to 11, which is not true. So this is an inconsistent solution, we cannot find any solution. So you can see this is an inconsistent system. Here is an application. A man walks at the rate of 3 miles per hour and jogs at the rate of 5 miles per hour. He walks and jogs a total distance of 3.5 miles in 0.9 hours. How long does the man jog? So we say that let x represent the amount of time spent walking and y represent the amount of time in jogging. So the total time is 0.9, so x plus y is 9. And we are given the total distance traveled in 3.5 miles. Since distance is rate times distance, so according to this we can form this equation. And then after forming these two equations, we can solve them very easily by substitution, elimination, or by graphing method. So I just gave you a quick overview because we have already solved the system of equation in college algebra. You can have a quick overview of this.